Are you guys ready to rock? Because it's time for some geology. You ready to rock?
Yeah.
Welcome to the Science Nights. I'm Josh.
I'm Adam.
I'm John.
And John's freshly back from another country with
I am.
other rocks. They were different rocks.
They had different rocks. Yeah. Mountains were
They were
rocky.
Swiss rocks, so there were holes in them.
Everything looked like granite to me. Like giant
Did you
granite.
take it for
mountains.
granted?
I did take it for granted. No, I took lots of pictures.
Of the granite.
Yes.
Nice.
We before we get into geology, I have a correction that I need to make. Episode 8, Fun with Physics. I called the three-masted, not four-masted ship the Discovery. It was actually called the Wyoming.
Oh. Good.
Yeah, I think there's a couple of those. Like okay, so full disclosure, video watchers get the advantage of me editing it, like in detail, which means that I can put up like Josh is wrong,
Right.
like with it. So if you really want to see if we know what we're talking about or if we check ourselves, the YouTube video is the best way to do that. But for you audio listeners, I totally understand the stuff I've made wrong. And I'm going to try and do a better job of...
Or they never heard the stuff you made wrong.
Yeah.
He didn't understand it. Yeah, there are people who are walking around right now
It's
talking about the Discovery.
with 4 masts. It had 4. Watch.
Yeah.
No, but I put up a picture of...
Watch Science Nights, bro. Do you even watch?
I put up a picture of the Wyoming, and it
Nice.
had 3 masts, and I was like, nope, 3 masts. Nope, it's called the Wyoming. I got something else wrong in there, too, and I made it known. John, literally said, and for the 3rd time, Josh is wrong. So,
Hey,
that's good.
That's why we encourage peer review.
Yeah,
So-
absolutely.
And we
So
can't
check
be
me
right about
better.
everything, but we tried to.
Yeah. All right, now on to geology. So, let's talk about rocks.
Yeah, hit me with your best rock.
Geology comprises the study of the solid earth and the process by which it evolves. Did you hear that? Geologists are evolutionists too. Geologists help provide primary evidence for plate tectonics and the history of the life of the earth. In modern times, geology is used for mineral and hydrocarbon exploration and for evaluating water resources. The discipline helps scientists understand natural hazards and recurring environmental problems. Other interesting parts of geology include archaeology, paleontology, and paleobotany. Does anyone
Palabotany.
disagree?
No. Watch
Sounds
the
good
video
to
to
me.
find our mistakes.
So Adam and I started looking up the notes for this a couple days ago, and he asked me a very, very interesting question. Do you remember what it was?
I do. It was, well, what would geology be called on Mars? Because geology implies Earth.
Yeah.
You know. So if we're going to, and I mean, that would be true for any rocky planet we
Yep.
went to then.
Yeah.
So it's actually still pretty much referred to as geology, just they specify Martian geology. But
Right.
there is another name, a kind of catch-all term for Martian geology. Adam?
Areology.
Yep, areology, coming from the name Ares.
Yeah.
Oh. I was going to say alien rheology. No? That's
I
not where it
missed
comes
you
from.
so much. You know that? I did.
Somebody's got to play dumb so you
No, I
guys
love
can
it,
look
dude.
smarter.
I can definitely see it. I mean, I can see why we would still call it just geology at this point.
Yeah.
You know? But after we, once we're out there among the stars.
And it's a more common thing.
Right.
Yeah.
Then it would just be weird to call it geology when we're studying like 1,000 other planets.
And it would be
too. Yeah.
confusing. It would confuse people needlessly.
Right.
Right? So the creation of another word that describes it makes more sense.
So just to clarify, in planetary science, the term geology is used in its most broad sense to study the solid parts of a planet and moon,
Right.
or moon. But it incorporates in the planetary sense. It incorporates geophysics, geochemistry, mineralogy, geodesy, and cartography.
Okay. What
and
about
then-
archaeology, paleontology, and paleobotany?
I
those as
don't
well?
know because paleobotany I don't know because there's no plant matter.
Yeah.
That's a good one, right? Because we haven't found any.
Yeah.
There's no point in changing it yet.
Yeah. Archaeology.
Can you imagine a rock plant?
I mean, what does paleo imply though?
Isn't it a time frame of the Earth? Oh, let's look at that.
Right. I think
Yeah.
so.
The
So, I mean, that would-
Paleozoic?
Paleolithic.
But that wouldn't.
Paleolithic. Mesozoic. Cenozoic.
Yeah.
Okay. Yeah, no, I'm with you. I'm back. I was off for a second.
Yeah, you were gone. You were in a different country.
Yeah, it's also, I haven't had a
Jet lag.
I think I took
so.
Earth Science in the 11th grade. But I did enjoy that class a lot. My teacher was pretty rad. So, Mr. Lee, bald guy, big Saints fan. Don't understand it.
It's a Greek word. It comes from paleo, meaning prehistoric times, onto meaning beings, and tology meaning the study of.
Right.
Yeah.
So I figure like then it could still be paleontology somewhere else
Sure.
if we're studying the ancient past of a planet.
And I
you
guess
know?
when I incorporate those three into geology, it's really you're studying stuff in the rock itself.
Yeah.
Right.
Yeah.
Which-
fossils.
Yeah.
things
Exactly.
Like that. Yeah.
But let's move on from the definition of biology and into some of the greater discoveries of biology. And this one was actually a little bit harder than the other ones. For chemistry, you can name pretty much like Marie Curie and
Right.
Louis Pasteur, and like you can pull these names out of your head because you're like, I know what these guys did and stuff like that. Geology is a little bit harder for me. We have to start off with Nicholas Steno in 1638. Not 1638, it's when he was born. But he was the first one to propose the law of superposition in geology.
Right.
So the law of superposition in geology is an axiom that forms one of the bases of the science. In the plainest form, it states that in undeformed stratigraphic sequences, the oldest strata will be at the bottom of the sequence. So it's
Right.
just like the lower the strata, the lower the layer of rock, the older it
Right.
is.
It's them figuring out that they could basically look backwards in time.
Yeah,
that
and
way.
and using that, I thought one of my favorite things was like when Bill Nye debated with Ken Ham.
Yeah.
And he was talking about it, and he's like, I can't remember what those little crustacean-y, like, tiny things were.
Nautilus?
No, but I can't think of it. But he's like, basically, you find it in this layer.
Yeah.
And he goes, you want to mess up the theory of evolution and stuff. He's like, find it in a layer like 10 layers higher. He's like,
Absolutely,
and then he's like, then
Right.
we're going to have to completely re-question what we're talking about. But we know that it's not moving up through the thing.
Right.
So we know that, like, this is where it was.
So that first was theorized in the 17th century.
Yeah.
So before America was a
And
America.
and a smaller use of this exact same thing is like just like core samples.
Yeah.
Yeah.
Yeah. We'll get there.
Oh, sorry.
We'll
Anyway,
get there.
sorry. Anyways,
No,
yeah.
no. But you are absolutely right. It's like a cross section, a straw, just sucks out a sample of an ice core or something like that.
Yeah.
We saw a lot of strata when we took our trip to Eastern Oregon.
Oh, nice.
Yeah,
I don't doubt it, man. You
the
crossed
scenery
over the
was
Rockies.
Amazing. Yeah.
I love road
So
trips.
from Nicholas Steno, we move into James Hutton, who in like the 1730s, 1740s, he originated the theory of uniformitarianism. Now, I know it's a big word, but what it means is it's a fundamental principle which explains the features of the Earth's crust by means of natural processes over geologic time. It's also the assumption that the same natural laws and processes that operate in the universe right now, at this moment, are the same principles and rules that governed the universe in the past.
Right.
Yeah.
And eventually everywhere. I guess
Yeah,
that would be
and apply
added.
everywhere.
Right. Yeah.
Sorry. Yeah. It was first. The idea was first developed by James Hutton, and then later on, it was actually put into words better than the words that I just said. But this is. I picked James Hutton because like he used the Earth as an example. He was one of the first ones. It's got to be old. Like it's
Right.
got to
Yes.
be like
Right.
way old people.
Yeah. Like not 1,000 years old.
Yeah.
Yeah.
It's like it makes no sense that the Earth is 6,000 years old. That's impossible.
Yeah.
Yeah. And it doesn't make sense, but so many people believe it.
Yeah.
And it, you know what?
Or
And
that
it's-
it's flat.
Yeah, I can't wait till the pseudoscience episode because I want to jump on that bandwagon, baby. Like, God.
But he was the one that first came up with the idea that we all actually agree as it's wrote. It's true. If it acts natural now, it acted natural in the
Right.
past.
So we know that the same laws of physics apply now, applied in the past and everywhere in the
And that's
in
a
the
big
universe.
That's a big
deal.
assumption to make,
Well,
right?
it's not just a big assumption, but it's a big deal. So once you realize that, you can start using that for experiments, right? Because now you have a baseline, like you understand,
Yeah.
like we know,
That's
like
gravity.
isotope decay and stuff like
Sure.
that. Like,
That's the beginning of so many different
Exactly.
discoveries we've made since then. you
And
know.
it blows my mind that it was an Earth-based scientist, like not like he was based on Earth, but his main focus was the planet.
Maybe
and
he
not,
came from
like,
Right, and not the stars.
the stars, right?
Right.
Which is where you equate and associate most of the other greatest contributions in science.
Well,
Well, a lot of them.
you got to think too, though. Like, it is kind of weird when everybody else is looking up. He was just like, "What's under my feet?"
Now, I'm not saying he was only
Yeah, no,
a
I'm sure
geologist,
he
because
had.
just like every other British scientist at the time, they were into everything.
Oh
Well,
yeah.
you have an
He was probably
interest
trying to
towards
make
science
gold at
and,
night at his house doing alchemy. Like,
And all of this uniformitarianism still before 1776.
Very nice.
Well, at least the original theory.
Yeah.
So then we move on to William, and he had a nickname. His name is William Smith, but they called him the Strata.
the Strata.
Because
That's
this
a
is the
dope
guy
name.
in Britain. He was
don't
the
have a
guy
cool
that
nickname.
made the first geologic map. And if you look, I think I included an image for you guys over there.
Yes, you did.
It's cool, man. Like it shows
Very nice.
raised areas. It's almost topographical, but it also shows the different kinds of rocks and the different strata and stuff.
Yeah.
And he color coded it, and it's amazing. And that map is 300 years old, almost
Yeah.
200 years old.
That map is before planes and satellites.
Where did he,
and
you know.
he did that without
Like
even
just walking around and observing.
With
you know.
with colored pencils,
yeah. And
Taking
you know, granted,
measurements and
maybe
things like
pastel.
that.
I don't know. How do you do that back then?
I
That's
imagine
a-
he probably had an artist friend help him with the actual rendition of it, but his categorizing of the different rocks and the different geologies, the different strata and stuff in England, it's awesome.
That's super cool. This area looks intense.
Is it the southern tip?
No, it's like the eastern.
Oh, okay, yeah. So, you
No,
can
it's like
Yeah.
southern.
yeah, you can see on the edge of it, like the cliffs of Dover. That's where like that first episode of Cosmos, I think, is there.
Oh yeah,
Yeah.
okay.
Yeah,
Uh-huh.
and Neil deGrasse Tyson like walks in front of it, and he goes, "These
Right.
cliffs formed over hundreds of millions of years."
6,000.
Whatever.
I meant 6,000.
From William Strata Smith, we move on to Sir Charles Lyell. This is the guy who popularized and finalized the theory of uniformitarianism. He wrote it down,
Right.
and he was like, "Okay, this is what it actually is."
Oh.
Well, at the time, I imagine that was a hard idea to get over on people.
Sure.
You know?
Yeah. It blows my mind that it took. So Sir Charles Lyell was born the year that Hutton died, and so
Gotcha.
Hutton was the one that made the theory. And so,
Right, yeah.
Yes, John, you have a question.
No.
Then why'd you raise your hand? Raise your hand for questions.
Paleozoic is a thing. So Paleolithic is too, and I know what you're talking about.
Paleolithic is the rock.
Yeah, Paleozoic is the era.
Yeah.
It takes the Permian.
All right, so I was wrong, but
it's-
the word exists.
Yeah,
Yes.
All right.
It is
No,
a
no, see,
word.
I'm cool. I'm good.
So not only did he do that, not only did Sir Charles Lyell come up with a written theory of uniformitarianism, he also gave the first scientific explanation for earthquakes and backed up the idea of the building pressure in volcanoes or what makes them erupt.
Right.
I know I spelled building wrong there. I'm sorry. And he also coined the currently used names for the geological eras: the Paleozoic, the Mesozoic, and the Cenozoic.
Nice.
Do you know what era we're in?
I
I didn't say epoch. I just era.
would no, not any more than maybe like the modern era. Is this the
Cenozoic? Yeah,
Is
Age
that
of
the-
Mammals.
There you go.
Yeah.
Age of Mammals. We got it. We figured it out. We
There we
Wikipedia'd
go.
that shit.
Yeah.
We live in the Holocene epoch, the Quaternary period, the Cenozoic era, and the Phanerozoic eon.
Ah, yeah.
All of those are just
nice.
different ways of describing the rock that's being formed as we speak.
Gotcha.
Okay.
So the Cenozoic is definitely zoology, zoic, that's us, that's animals. But the Holocene is a way to describe a rock.
Yes.
The Quaternary is a way to describe a rock. So I don't know, it's really cool.
Yeah, no,
It's really
very
cool.
interesting stuff. Yeah.
I really hope that I was right about the Quaternary thing.
Oh, you'll find out in the video.
Yeah,
Oh,
exactly.
yeah. Audio listeners
Or you
will
can
hear
tell
none
us.
of this.
Audio listeners can still fact check. Like maybe if you're bored.
Oh, they'll hear this.
Yeah. No. Fact check the ever living balls out of us.
Yeah.
Not
yeah.
maybe not that exactly. Don't do
Just
that.
John.
Yeah.
So, moving on. We have to keep moving. There's a lot of actual discoveries left. We got William Thomson, a.k.a. Lord Kelvin. The
Okay,
man, the
very
myth,
nice,
the
very
dude
nice.
that made the best way to measure temperature. And if you want to see me learn that, tune in next week when Steven tells me what it is. But William Thomson, or Lord Kelvin, attempted to find the age of the Earth by explaining its cooling time and estimated it somewhere between 20 and 400 million years old.
Hey, not
he
bad.
wasn't even close.
No, he's
No,
not
but
in.
that's a good. That's
That's
start
better than
compared to-
6,000. He's going. Wait a minute.
Well, no, there's been other people throughout the past that have postulated the age before, and they've been all in the millions. Like,
Yeah.
some people are like, it's a million
yeah,
years
but
old.
I'm just saying.
You just really want to nail that creationist hit, don't
Now-
you?
A little bit.
Yeah.
Is this the guy that
Sorry.
did it based on like the cooling of a potato?
I don't know that for sure. But, I mean, his work with thermodynamics, maybe.
Right. Well, that's kind of what I was thinking. I mean, and with temperatures and stuff. Yeah, definitely. I remember that it was based on like how quickly the center of a potato would cool, and he basically tried to calculate then how quickly the Earth would cool, based off of that.
Well, I looked up Lord Kelvin potato, and I don't really get a good hit.
I mean, it may have been. I may be confusing him with somebody else later.
Sure.
Or
I'll try and look that up and put it in
right.
the video.
Yeah. Anyways.
But yeah, I love that. Okay, so Kelvin is also a measurement of temperature. We have Fahrenheit, Celsius, and Kelvin. Kelvin, absolute zero is the coldest anything can ever be. It is
Right.
It is neutral heat, like no heat, none, and it's unachievable by man. We have yet to reach it, and we've yet to see it.
We don't see it in the universe anywhere
Yeah.
either. Everywhere there's like at least one
Yeah.
molecule or something vibrating.
Yeah, right. So Kelvin is a much more, I would say, precise way of measuring temperature.
A much more scientific way for
Yeah.
sure, right? And they didn't want a negative side of the spectrum. That's why it's set up the way it is.
Yeah. From Lord Kelvin, we move on to Alfred Wegener. I think his birthday is not 1180.
It's probably Wegener.
Yeah. But he proposed that all continents once formed a single landmass called Pangaea,
Ooh, puzzle planet.
and it broke apart via continental drift. Yep. So his hypothesis is controversial at the time because it wasn't even widely accepted until the 1950s.
Yeah, I was gonna say it took a long time
Yeah.
to get people to believe that.
Discoveries such as paleomagnetism provided strong support for his continental drift and thereby a substantial basis for today's models of plate tectonics. So this guy right here, he's the one who proposed Pangaea and plate tectonics back in the 1800s.
So he was just balling hard. He was like, look, I understand some things. And everybody was like, yeah, we're not so sure.
Well, I mean, you're trying to convince people that this huge landmass just moves. You know?
So yeah, he was born in 1880 in Germany. He was a geophysicist and a meteorologist, and he was a polar researcher. So he would go to the poles. Duh. And then last on our long list of geological discoveries and excellencies, we have Arthur Holmes, who lived from 1890 to 1965. And his two major contributions to the understanding of geology, he pioneered the use of radiometric dating of minerals and was the first Earth scientist to grasp God, I can do this, to grasp the mechanical and thermal implications of mantle convection, which eventually led to the final acceptance of plate tectonics.
Very nice.
This is actually a really cool diagram.
His radiometric dating is eventually how we figured out how to determine the age of the Earth.
Yeah.
And, gentlemen, the age of the Earth, off the top of your head?
4.5 billion years.
4.54
Yep. Yeah.
Yeah, that is based on...
Give or take 10,
Yeah.
100,000 years or whatever.
That is based on the latest dating that we have from
100,000.
meteorites.
10,000 wasn't going to be enough, so
I would say plus or minus like 10
mil.
million years.
Yeah.
Realistically.
Yep, because
that's
it's based on
accurate.
it's based on
Right.
the decaying isotopes found within a meteorite.
Right.
But there you have it as far as we know. As far as I've selected the most important developments in geology. I want to spend the last little segment of this episode, just like we do the other discipline episodes. Let's talk about geology from our perspective. What do you think about it? John, I think you're kind of itching to go.
Yeah, well, one, I just want to say that I do love archaeology. But I was talking to Josh about something before the show that I've always thought was super interesting. And it's the fact that the poles on the Earth reverse
The magnetic
with
poles.
time, the magnetic poles. And I was rereading it today because it's been a long time since I've actually read anything on that. I just remember it from school. And I always thought it was, super interesting. And one thing I found out about it today is so the pole has been, continuously moving since the early 19th century, since they've really been tracking it. And it was previously in the early 19th century moving at like 10 miles per year. And now the magnetic North Pole is moving at 40 miles per year, and it's gone about 600 miles since the early 19th century, which is
So
kind of
naturally, when John told me this, I started asking questions. Well, why did it speed up? What?
And see, that they're not 100% sure of. The thing that they've decided is that we are well overdue for pole reversal. They also know that it's not like a sudden flip. It's not just going to be like, bam, south is north, north is south.
Right.
Yeah.
It's going to happen over hundreds of years. And the other thing is that other poles will actually appear in that time like completely out of whack. So like you could have a pole that was like to the east that for a brief span, which might be 30 years, would actually show up. But
So the next question I asked John is, what does this do to magnets that are in use today by like engineers?
nothing.
So that's a relief, right? So the maglev trains aren't going to start going
They
backwards.
float up and suck down on the train and create huge friction, like all burst into flames.
Yeah,
The only thing that would
exactly.
screw up would be magnetic north.
Yeah,
Yep.
so that just means
And
that
our
your
magnetic
compass is-
field. So they said it's a possibility that during the transition, like it will weaken.
And would have higher
Yeah, and there's
radiation,
apparently like doomsday theorists that are
Worried
have
about
things
higher
like that when it's flipping, the magnetic field will actually disappear, and then we'll be prone to like solar flares and solar radiation, and it's going to destroy the
cosmic
Earth.
radiation.
But they said they have no evidence that it's ever fully disappeared, and they have no evidence. They've studied all kinds of stuff in regards to this, like all the way down to like oxygen in plant fossils and stuff like that, and there just nothing shows that there's ever been any issue with pole reversal beyond south becomes north. And they also said even in a weakened state plus our thick atmosphere that there's still really not any more fear of a solar flare. If it was big enough to get through all of that, then even when it was strong, it still would have got through. But anyways, yeah, I just thought that was super interesting. I think it's a crazy thing to think about. And it's done it literally hundreds of times in the past. And they actually use the lava that comes out in the ocean to all the iron in it goes one direction. And that's how they study.
Okay.
And then they'll find flows, older flows, and they're going the opposite direction. And it flips. And that's how they were able to figure out.
Huh.
Yeah. And the last one was about 780,000 years ago. And they were saying that it should be about 300,000 years per flip. So they're saying we're overdue.
So then that was the next question I asked John, was like, is this man-made? Is this because of our interaction with the Earth? And John's like, oh, no.
No.
Been happening for...
We don't have the power to...
They believe it has
Because of our
something to
magnetic
do
field,
with the liquid metal ocean around the core.
Sure.
And stuff like that in the moving, because it creates electricity, which is what creates our...
That's
Right.
that's what I think people need to wrap their heads around more, is like the Earth itself is a magnet because it's got a semi-molten iron core. And it spins.
Yeah.
So that means that you're gonna you are just generating an electric.
The other
or a
doomsday
magnetic
theory
field.
is that this throws the Earth off axis.
I was gonna say that.
Yeah, and like even a slight amount, like if it messes with the core,
Yeah.
and then say the core shifts because of all of that, right? Then it throws the Earth off axis even a little bit because that's. But they said studying like glacial movements and stuff throughout history that nothing shows anything, because that would completely change.
Yeah, that seems less likely than losing the magnetic field, I would think.
You want to know what's more likely to throw off the tilt of the Earth or the spin of the Earth?
Well, it doesn't spin; it's flat. We're on a pizza box.
Is the eruption of the supervolcano in Montana or in Yellowstone.
Oh.
If that thing blows,
I
we're
don't
definitely gonna move.
I watched a documentary on that when I was like 16, and it terrified me. I was just like, that thing's gonna blow. We're all gonna die.
Yeah.
They're like measuring like the ground swell. Like every year it's going like 2 or 4 inches like higher because of the magma. I'm just like, stop! Somebody poke a hole in that and let out some pressure. Like,
What have you got for geology, Adam?
Well, I mean, we kind of talked about it a little bit earlier, and always my favorite part of geology was, like you mentioned, archaeology and
I think it's-
paleontology. I think all kids were interested
Yeah.
in dinosaurs.
Dinosaurs, man.
and
the
fossils
idea of
and
digging
things
stuff
like
up
that.
and discovering things, like how
Like
I used to
time
dig in my
capsules.
yard and piss my dad off. Like, what are you doing? Looking for treasure,
In the trailer park?
right? Dad, look what I found.
It's
what?
a bike, son.
I think it was the person who lived here before us.
During our trip to Eastern Oregon for the solar eclipse, we stopped by the John Day fossil beds.
I was gonna ask you about
that.
that.
Was very interesting
Yeah?
experience. So, you got
Any
to see,
fossils? Sorry, I just gonna tell me.
we got to see a little bit about like the history of the area and things like
Nice.
that. I do have some information, so we'll probably do a more in-depth episode at some point for that.
Sure.
You know,
Yeah.
but we got to see.
Any fossils on hand?
Yeah, there was a lot of display cases with,
Sure.
with fossils and skull heads and not like dinosaur skeletons or anything, but just pieces of stuff that were found in the area. Like I forget how many years ago, but all of Eastern Oregon was like a tropical area, you know. So
Yeah.
it had all these crazy like animals there that were huge compared to.
Yeah, there was a huge
Well,
where
and-
Montana is just a lake,
Well,
Yeah.
no,
and it was like a middle continent-sized
And then
lake.
to the change now where Eastern Oregon is more desert-like temperature.
you're talking like insects in the old period, like the size of like birds,
Cats,
like
like
big
modern
birds,
cats. Yeah.
and the direct reason is how much oxygen the Earth had and the concentration of oxygen on the Earth. So they found that huge alligator, right?
Yeah.
As well as the giant snake. But the alligator, I thought it was awesome when they finally figured out what it was. They're like, it's an alligator's vertebrae. It's like very clear. And then they held it up to like a regular
Alligator.
like, standard. And then even like a saltwater crocodile, which is like the biggest, just to show. And this thing is like 4 times larger, 5 times larger,
Nice.
like easy than
Yeah.
those vertebrae. And you're just like, get out of here.
So before we move on from fossils real
Yeah,
quick,
sorry.
I think it's important to note that they're not actual bones. The calcium in the bones was replaced by rock.
Right.
Yeah.
So
And their fossils are rocks.
it is actually a rock. Now, yeah.
But it's so cool because like it has to happen in a very specific way for it to actually become fossilized.
Right.
And
Yeah.
most of that means instant death. Like these guys have had to die right there where they stood.
Quickly, or we're like covered with something. So
Yeah, like a
to
silt
preserve.
came over. And
Right.
Dude, like a
literal-
mudslide. Mudslides are
Yep.
great for sealing out oxygen and preserving.
Yep.
One really cool thing, one of the other really cool things there, although it wasn't operating at the time because it was during the weekend, I assume, and solar eclipse, people had days off and stuff, but they had a whole, like, you could watch through a viewing window, like the laboratory area where they would clean up fossils.
Oh, what?
And, yeah,
So you like
these-
Jurassic Park rided it, like and the little gene thing.
Sorry,
started
it's
telling
kind of
you
a
what they're
ride.
doing.
But there's like these big, huge machines and stuff that would
Yeah.
do all the different.
That's
things
so
to
cool.
the fossils. Yeah.
Was
It
there
would-
no like?
It would
gene
actually. We didn't
helper?
have a whole lot of time
Mr.
to
DNA.
spend there because we were already going like an hour and a half out of our way just to go there
Yeah.
versus
Yeah.
where we were camping for the eclipse.
Worth though.
But it would definitely be worth going back to check out sometime. There's lots of trails. Like there's a whole.
And
I have a whole map of all the trails you can walk through the area.
Can you rent a kit and go look for fossils?
You
could do that in Montana.
You probably could. I'd imagine anything on the trail has actually been right. But you could always walk off the trail. There's a ton of.
You ever been to
It's
the?
not all
There's
found.
a ton of. You want to?
never all
What you were
found.
saying earlier, you wanted a road trip. It's only about 8 hours from here.
Damn it, that was my question. All right, we gotta wrap
All
up.
right, you.
But
What
mine,
do you like?
Mount
Quickly!
St. Helens.
Just kidding.
That's
think-
it. So volcanoes in general.
Volcanoes
right.
in general are fascinating.
Right.
Super fascinating and terrifying and
Yeah.
powerful.
Well, yeah, okay, but
that's what makes them fascinating.
St. Helens erupted in '83, I
Yeah.
believe.
Yes.
Um,
Or 82.
I'll look it up real quick while I'm
Whatever.
talking. But
I can't remember. I know it was very close to when I was born.
so what happened is like the top of Mount St. Helens blew up, Actually, the last eruption from Mount St. Helens was 2008, but it was small.
Yeah.
1980?
Oh, 1980.
Yeah.
Okay.
We're
Yeah.
all wrong.
My
So-
dad was on McCord Air Force Base and got to watch it.
Yeah.
Nice.
Like, that's
So
crazy.
the top of Mount St. Helens popped off and blew ash hundreds of feet into the air. And it
Hundreds.
covered,
I thought it went.
I don't know if it went,
Thousands.
whatever. It
I
went
mean, at
huge.
one point it ended up going all the way around the world, I believe.
Yeah.
But
Okay,
Oh,
so
jet stream and stuff.
that ash covered the entire area of Mount St. Helens, obviously, and a lot of area around it, essentially dumping petrified carbon on top of the ground and killing a lot of it.
oh yeah, definitely.
But in the last 10 years, 15 years, that area has become one of the most fertile parts of Western Washington, because
Except for near the mountain.
well, yeah, but the valley around it,
Yeah.
it's crazy gorgeous.
Yeah.
I'm gonna have to put up a
'Cause
picture
all
of
that ash and stuff from deep inside the earth coming up is great nutrients and fertilizer for the
for the
for
plant and the
everything.
ecosystem.
But I just mean
and
like
stuff.
the like
Oh, the side of the mountain?
silty hillside and like all the area out flat to the observatory that's the closest you
Yeah.
can get without actually hiking. It's still just like barren.
Oh, sure.
Which I still want to go out there because then I could pretend I was on Mars. Like,
another road trip.
See, I would
like what's that guy doing using the viewer scope?
if we go do stuff out on location, which I'd like to do, like when we do the wind, when we do like alternative energy and stuff, when we do the wind power one, we should go to like Yakima, where the wind turbines are and stuff like that. But I would love to go to St. Helens. I'd also like, I know this is never gonna happen, but if we can make it to the Grand Canyon, we can get a real in-depth demonstration of what the strata actually are.
Definitely.
I'm sure if I can just grab pictures from the internet and show
Definitely.
you, but if you want to see the power of water versus earth, right there. And then I guess the last thing I want to mention about geology is the time scale of geology is far greater than any living thing. Like, I know that nautilus haven't really changed as far as their evolution goes in a long time. Sharks and alligators really haven't changed their evolution in a long time. That doesn't matter. The earth is ancient.
Right.
Yeah.
There is no... all of this like posturing and politics and all this stuff, like all the hate or love or whatever's going on, it doesn't matter. Like the earth is gonna be here when we're gone.
Right.
Yeah, well, I mean, it doesn't matter to the Earth, but it matters to the people living on it.
Sure.
Because
Yeah.
we're destroying our environment. We're not destroying the planet.
Yeah, no, the planet ain't gonna die.
No.
Yeah.
I mean, we might
The
we might
planet's-
hurt it, but then it'll heal once it
It will
gets
kill
rid of
us.
us. Yeah, like exactly. It'll be like,
And then
I've got an
we'll be better
infection,
off.
antibiotics, eruptions everywhere.
Yeah.
You're all dead, and now we begin anew. Like,
I like Jim Jeffries. He's like, the earth is gonna go, I'm gonna do dinosaurs again.
yeah.
All right, before we leave, a couple of things. We want to invite peer review. If there's something we got wrong tonight, please let us know, and we'll
Please.
do our best to police ourselves as well.
Yeah. For sure.
But science is a peer-reviewed process. We are not scientists, but we'd like to be. And
Science
and-
enthusiasts.
Yeah.
Yeah, science communicators.
Scientologists.
No. No. Another thing, we are now available on iTunes and most of your
Yay.
favorite podcast catchers.
Yep.
If you
And Stitcher and TuneIn Radio and Google Music. We're all over now.
Yeah,
Just
we're
search,
everywhere.
Search
We're
Science
an
Nuts.
omnipotent podcast.
if you have enjoyed this series of episodes on just the overviews of the sciences, let us know because I've had fun doing these, but I'd like to do more if we can. Or, but now, ladies and gentlemen, the next subsequent episodes are going to be a little bit more specified. Other than the ones that we have with.
Sorry.
You feel like your homework's done and you can get into the project now, right?
Well, exactly. It's like I did the simple worksheet, but now I want like the 2-week project.
Yeah, I got you.
Yeah.
I got you. But
You want
I
the road
felt.
trips.
Yeah, I want the road trip.
You know, I feel like it's important to get a solid basis in before we decide
damn
to
you.
start delving.
Go back to Switzerland. Germany, wherever the
Dude,
fuck
I
you
would.
are.
I would.
All right, kids, that's enough for today. Please be sure to like and subscribe and hit all those reviews and give us some ratings. And for the love of everything natural, get into some science. We'll see you guys later.
Bye.